So you've already had a play with this worksheet. Basically, it's a look at linears, quadratics, cubics, and quartics in factor form. Now, I'm just going to skip over the linear and jump straight to the quadratic. So here's our quadratic, and you can see that if I move the A and the B slider, what we end up with is this function here, x plus 2.4 in brackets times x plus 0.6. Now, hopefully, while you were investigating this, you should have noticed that plus 2.4 lines up with this point here. That's negative 2.4. And this point here, negative 0.6, lines up with this point here, 0.6. And so, if those numbers increase, if that's x plus 5, then it lines up with this, negative 0.5. And so this b value and this c value, the thing in the brackets that's added to x, is directly affecting the roots of this equation. Now, of course, that doesn't just work for cubics. It works for, it doesn't just work for quadratics, it works for cubics as well. So here we have 3 roots. It passes through 3 places. Negative 5 passes through negative 1.6 and it passes through negative 0.8. And that's a direct result of these 3 functions. If I change one of them to a negative, that means that the root's going to be positive. And of course we can take this all the way to Quartics. If I zoom out, let's see, get a really good look at this. Maybe just try to calm this function down a little bit. You can see we have 4 zeros. Negative, if we look at our function, you can see we have 4 zeros. We have a 0 at negative 3.6. We have a 0 at negative 1.2. We have a 0 at 0. The reason we have a 0 at 0 is because we're multiplying x, and that's x plus 0. This bracket here, x plus 0. So it's going to have x plus 0. And then we've got an x minus 1.2, and that's going to give us a root of x plus 1.2. Okay, so this is a quartic in factor form. We're looking at factor form here. Now, of course, what if I took the whole function and multiplied it by something? Let's try that out. So I've just added a new little piece of the puzzle, a multiplier. But really it's an a value out the front of this thing. So you can see I've got my a value here. It's a value of 1.5. If I increase my a value, we can expect to stretch this function upwards. Or I should say stretch it away from the x-axis. You guys know all of this because you've done function transformations. So you know that if I take a function, which is what it started out as this function here. If I take this function and multiply the function by a factor, I can expect some dilation around the x-axis. And similarly, if I multiply it by something like 0.5, it'll squash it down. And, of course, I can turn the whole thing upside down by multiplying it by a negative. So, a couple of things here can happen with factor form. We've got these bits here, and we've also got what they call a dilation factor out the front here. We can call this our dilation factor because it's dilating our function. Alright, that is factor form of quadratics, cubics, and quartics. It affects the root or the roots of our function by that number here. There is a little bit of trickery here, so I'm going to have to make one more video to show you something a little bit different with these, but there's the basics.